Hey guys, how's it going? I'm Halamatu at Kira Tutoring. We provide low-income students with free SAT tutoring. So if you're low income and need some SAT guidance, then all you literally have to do is visit our website, go to the apply page, read the guidelines carefully, and if you're eligible, then apply. So as you already know from the title of today's video, I'm going to talk about right special triangles once again. So in one of our previous videos, I reviewed the 45, 45, 90 special triangle. I kind of talked about how we could identify the triangle, its special feature, and just a couple of practice problem questions to test your knowledge. We're basically going to do the exact same thing on today's video, but using with a different triangle, because here at Kira Tutoring we're all for diversity and no discrimination, but mainly because as I've said before, there are two right special triangles in geometry, and I figured since I've already covered one, why leave the other one out, you know? Alright, so triangle numero 2 is the 30, 60, 90 triangle, and this is just a triangle where the two acute angles are 30 and 60, and it's actually formed when an altitude is drawn from a vertex of an equilateral triangle. So if I copy this triangle and place the copy right in front of it like so, you'd see that each internal angle of the triangle, the equilateral triangle, measures 60. So that's 60 here, this is also 60 degrees, and those here add up to 62. Alright, so now if I come across a triangle during the test, how do I know whether or not this is a 90-60, a 30-60-90 special triangle? Well, number one, you'd be given both of the internal angles, that's 30 and 60. You've already got this one here, the 90 degrees, because that's the most prominent feature of a right angle triangle. Like a right angle triangle isn't right unless it has an angle that measures 90 degrees, right? So that's already there. But one more thing, guys, like, don't ever assume a triangle is right unless it's provided in the question or the drawing, whether it be direct or not. Like, don't ever assume, because this triangle here, this definitely looks 90 degrees material, like a right triangle material. Actually, it doesn't, but let's imagine it does. This looks 90 degrees material, but who knows? It could be 91. It could be 89.5. So yeah, like, don't ever assume it's a 90 degrees. Don't ever assume it's a right triangle unless it says so in the question or the drawing. So number two, you'd be given either internal angle, so that's either 60 or 30, and in either case all you have to do is subtract the given angle from 90, so that's 90 minus 60 for this triangle here, which gives us 30, or 90 minus 30 for this one, which gives us 60. Or you could always use the name of the triangle, like 30, 90, 60 for reference. So we've already got 90 and 60, well this has to be 30, and here we've got 90 and 30, well this has to be 60. Alright, going back to this lovely triangle here, let me just clear all of that out. Oh, and I know I've already said triangle like a million times, so please bear with me, guys. So this triangle is special because of the relationship between relationship of its sides. Like, you could find the measure of any of the three sides simply by knowing the measure of at least one side in this triangle. So this triangle has its sides in the ratio of x to x root 3 to 2x. Oops, 2x. I don't know if you see that. Alright. And if you've watched my previous video, you would have known that the side opposite to 30 is x, which is like the short leg. The one opposite to 60 is x root 3. And the one opposite to 90 is 2x, which is the hypotenuse. And the hypotenuse is always the one opposite to the 90 degrees angle. Now let's look at some examples. So this triangle here is a 30, 60, 90 triangle, and we've got one side given here. Now let's find the length of the other two sides. First, since it's a 30, 60, 90 triangle, let's recall our ratio. So it was x to this x square root of 3 to 2x, right? And since the sides you're given, which is 12, or A here, is across from the 30 degrees angle, it will be the short leg, or x. So 12 here equals x. And to find the length of B, or the long leg, you simply multiply by the square root of 3. So B equals 12, x times the square root of 3, which we know already that x is 12, so 12 times the square root of 3 gives us 12 square root of 3. And to find the length of the hypotenuse, or C here, all you literally have to do is multiply by 2. So x times 2, or 12 times 2, that gives us 24. Alright, for another example, so this is also a 30, 60, 90 special triangle, and since we know that for sure, let's write down the ratio in the corner here because we might want to use it. So x to x root 3 to 2x. Alright, and in this problem here, we've got the length of the hypotenuse, or C, which is the one opposite to the side opposite to the 90 degrees. So let's write 16 under 2x here. And see how in the previous example, it was so, figuring out the lengths of the other two sides was so easy because all we literally did is like plug in for x in the ratio. So to do so, we need to find the length of the short side, A or x. So if 2x equals 16, then what's the value of x? Well, if 2x equals 16, then x equals 16 over 2, which is 8. So side A here is 8, and side B is 8 times square root of 3, which is 8 square root of 3. So this is 8 square root of 3. Example 3. So this again is a 30, 60, 90 triangle. So x to x square root of 3 to 2x. Alright, but this time we've got the length of side B, or the long leg, and this is honestly like the hardest it could get. So we know that side B, or the side opposite to 60, is 4. So let's write it down here. So this is 4. Then what's the value of C and A? Well, let's find the value of x first, or the short leg. So if x times square root of 3, x square root of 3 equals 4, then x equals 4 over square root of 3, right? And to rationalize this fraction, we multiply both the denominator and the numerator by square root of 3. So that's 4 over square root of 3 times square root of 3 over square root of 3. That gives us 4 square root of 3 over square root of 3 squared, which is 3. So x equals 4 square root of 3 over 3. And to find the value of the hypotenuse, or C, you simply multiply by 2. So 2 times 4 square root of 3 over 3, that's 8 square root of 3 over 3. And oh, and I forgot to mention something. So see this triangle here? Remember when I said that this results when, oh my gosh, height. This results when a height is drawn from a vertex of an equilateral triangle. Well, what the height does is it bisects the angle and it cuts the triangle into two congruent baby triangles. So if we bring back the good old duplicate here, well, this side is x and this is also x, so they both add up to 2x. Same length as side C, and this kind of helps you understand where this ratio is derived from. Yeah, and as always, I've got a question prepared for you guys. This is not really straightforward, aka most questions on the math portion of the SAT, so it definitely might seem undoable at first, but once you read it, you definitely get to an answer. You've reached the end of this video, guys. Thank you so much for watching. So if you found it useful, then hit the like button below and subscribe to our channel, because when you do so, it motivates us to create more content for you guys. And also don't forget to follow us on social media. We love interacting with you. If you've got any questions or any ideas for further videos, feel free to let us know in the comment section below. And yeah, that's basically it. Hope you guys have a spectacular day, and bye!